let me go through and give my presentation, and hopefully Dave Harold will come online and give his soon. This is my presentation normally given each year to summarize what has happened since the last meeting up until the present time in regards to asteroidal occultations in North America. So that means we're running from about September 2015 through earlier this week. Okay, next slide. Here's a summary by year, and I've broken it down by positive observations, reported misobservations, and then the total. Even though 2016 looks like it's down a little bit, you have to realize we're only a little bit more than halfway through the year. So I would expect that the numbers for 2016 will be as good as 2015 and 14 or even better, which is a good sign. Okay, next slide. Here I've broken down the observations by the number of chords that were recorded. Obviously, the more chords we can get, the better off we are. And this is where I have a few concerns. Again, we're only talking about halfway through 2016, so I'd expect the numbers to go up. But you can see, once again, the vast majority of reports show only one chord across the asteroid. And that certainly isn't our ideal situation. There's a lack of 3 chords altogether. We don't have any, I'm sorry, 4 chord. We don't have any 4 chord observations at all. We do have some that are greater than 4. So we need to get more people involved in getting observations so we get more chords. Okay, next. So here's a list of some of the best observed events from last September through this July. I'll let you just look at the list. I'm not going to read down through there. You can just kind of look at it for yourself. I've tried to list there why I felt they were worthy of the list. In most cases, it's because they are multi-chord events. And in many cases, they have an inversion model. Yeah, I got birds in the background. Good audio. They include an inversion model. And with Bella from March of this year, not only do we have 2 chords, which were well observed, but Tony and I were able to get down to the nitty-gritty of those light curves and find a new double star, and it fits the model very nicely. At one point, we even thought there might be a 3rd star involved, but that was a little bit beyond what we could glean from the light curves and be sure of it. Okay, let's look at each event individually then. Next slide. September 4th, 2015, Aspasia. Pretty good fit to the model. I haven't put in here the error bars, so that might account for some of the discrepancy we're seeing here. And the other thing I haven't had a chance to do, and I'll talk more about this later, is to look at different orientations of the asteroid. These were grabbed at the orientation predicted at the time of the event. And I'll talk more about that in a minute. Next slide. Asteropy, I guess that's how you pronounce it. Pretty good fit, only 2 chords, but we can get the inversion model to fit those 2 quite nicely. Next. Euclides from October. Again, 3 chords, but they are well spaced, which certainly helps with fitting the model to the observations. Again, pretty good fit. Next. No model for Felicitas, and 2 of the chords were quite close together, but even so, the fit to a nice smooth ellipse is quite nice. Next. A lot of chords across Eagly, I think that's how it's pronounced. Too bad it doesn't have a model. Maybe sometime in the future we'll come up with a model. We can go back and take a look at this, but you can see how well the chords all fit. So it's pretty round, I guess. Maybe a little bit of a notch in the northern pole there. Next. Before I turn my phone off. This one I put in, sure, the diameters, okay. This one, Branislaw, I put in only because it had one chord, but the one chord showed evidence of a graze. Ned Smith recorded this one, and the fit I made here is based on the miss just above it, so there's really no way to get an accurate diameter here. Well, I guess you can get an accurate diameter because you have the miss, and we'd expect the graze to be along that southern edge. There's always a chance the graze is along the northern edge, and the prediction wasn't all that great. So we really, this really can't be a model that we can use with reliability, total reliability. But it's nice little graze there at the bottom edge. This one turns out to be about 74 kilometers. I don't know what the actual size is expected to be. Okay, next. From earlier this year, January, Thyra, the model fit is not all that good, as you can see. We had a series of misobservations along the southern edge, and the observations that were positive seemed to fit the model okay, except maybe number 3. And again, that could be any number of reasons for that. I'll talk more about this later, but just to give you a heads up, we now have the ability to rotate this model and look for better fits. So instead of looking at the model in one part of its rotation, we can look at it throughout its rotation and get a better fit. And I tried that quickly with Thyra, and I couldn't find a better fit. So there's something going on with this asteroid that we're not quite aware of yet. You can see it's a little bit, the result shows a slight elliptical shape to it. Yeah, that's what I'm thinking, Tony. The model must be off in some regard, and I guess we don't have a lot of observations of this asteroid with occultation, so we have no way of checking the light curve. And I've let Joseph Direct, who runs the Dammit site, know about this, so he's aware that there's a discrepancy in the observation and the model. Yeah, for sure. Those southern misses, and we've checked those southern misses are important. Okay, next. Kaya, I guess that's how it's pronounced, in February. Again, lots of observations, no model for this one. Nice smooth ellipse, so about 94.7 by 73.7. All the observations fit pretty nicely, which is always nice to see. Next. February, again, only 2 chords, and unfortunately they were fairly close together near the southern edge. And you can get this to fit the model. There's no way to get a real shape out of it. The solution from occult is a circle 175 kilometers, and I move it around a little bit. We can get that to fit. I don't think we'd get a better solution in regards to this one, just because of the closeness of those 2 chords. From March, Alsonia, again, just 2 chords, and the fit isn't all that great. This is one I have not had a chance to try rotating the asteroid around. 2 chords are fairly widely spaced. Okay, next. This is what I mentioned when I showed you the list from March, 695 Bella. Both Richard Nolthanius and Robert Jones did see evidence of duplicity. in the light curve, and Tony and I, especially Tony, was able to extract times, and this is the chords together showing the double star. We have a double star separation of what, 0.0136 arc seconds plus or minus 0.0058 at a position angle of 59 degrees. So you can see the double star, and you can see how well the chords fit the model, and therefore it seems that they're a pretty good fit for that double star as well. So that's a pretty nice result there. Yeah, 4 chords, 2 each for the two components. So 2 chords for each. From April, I think David's going to talk about this. That's okay. You can go ahead. From April, I think David's going to talk about occultations with Cleopatra. This was from April, and we tried to get a lot of observations across this sky, and it looks like the prediction might have been a bit off, because you can see we have a lot of people south of the actual event that were listed. David was the lucky one and caught most of the chords. Art Olson was also lucky in that he caught a reemergence of the star in between the 2 lobes. So he caught the one lobe and then the reappearance, and then caught the second lobe. So he's the only one who saw that happen. And David caught the rest of the asteroid, and then people south of that had nothing. So it's tough to fit this one to the model. We have a model, but it's tough to fit. So let me see what we can do here. Go to the next one. So I took one of the models that's available online and just tried to fit the observations. And you can see we can make some sense of it. If you enlarge it or decrease in the size a little bit, you can see the on and off points of each chord. So there's a possible fit there. Next slide. I received information, I think from Frederick Vachier. I think he sent me information about different models they have, and this is a radar model from I think it's Stu Ostro, I'm not sure of the first name. And this is what the radar model would have indicated at the time of the event. So you can see it's not too bad a match as far as it goes. It's too bad we didn't have a few more chords across the top side there. And the next one I think is, oh, okay, I didn't post the other one. There's another one that didn't fit quite as well, so I didn't post that one. And this is one that Paul Malley talked about yesterday. This is a very low magnitude drop event with Pallas. So the light curves had to be studied carefully. And our OTE was able to extract times that were very reliable. And we end up with this nice fit to the model. Pallas is about 554 kilometers in diameter, according to this result, and then it fits into this model very nicely. There's a couple of models for Pallas, and this 101 model happened to be the best fit based on the observations. Okay, next. And Camilla from just a week or so ago, or not even a week ago. A lot of people wanted to observe this one. We're looking for the satellite for one thing. Those stations north of Camilla could have been in the path of the satellite, and I was one of those, and nobody was lucky enough to spot the satellite. The others that we have got a lot of chords across the asteroid, and you can see they kind of fit pretty well with the model that was proposed at the event time, and so I've kind of fit that in there. And I put down at the bottom that this is based on a published period of 4.843928 hours. And the reason I did that is because if you go to the next slide, as I mentioned earlier, Dave Harold has now placed in occult the ability to rotate the model through a small increment of time, like 1%, 2%, 5%, and 10% of the period. And then you can watch as this asteroid is rotated through to see how well it fits the chords. In this case, if I adjusted the period to be about 0.15 hours earlier, in other words, make the new period a little bit longer than it was, we end up with this better fit. Now there's one chord at number 6 that has probably a rather large error in it. So 6 is a chord that we can probably um, not ignore because it shows that an occultation occurred there, but maybe not use its result reliably to fit the model because the other ones fit so well. If you go to the next slide, Dave Harold did some further, oh, okay, that's the wrong presentation. Let me pull up mine, Ted, so I can get to that last couple. That is. Well, what it did was, and I'll just explain it. Dave Harold went through and looked at this observation of Camilla and a previous one. And he tried to fit the model to both observations the best he could. And it works out that by using the ability of occult to rotate the model through time, that we can come to a conclusion that the period I've published here, I've shown here, is probably very close to the actual period of the rotation for the asteroid. So there's a slight change in that rotation. It's a very small amount. And I really can't believe it, that file is not the one up there. But it's a very small amount, but it does show the value of having this ability to rotate the asteroid model. Instead of doing it by hand, you could input the times in the Dammit site. You could input the times, and it's Julian date, so you have to go through and figure out the Julian date. You could input those times and get the model as it looks around the predicted time, but now Occult does that automatically for us. And it's a really neat tool to have. And that was a suggestion I had for Dave, and I was so glad he was able to implement it. And I guess it wasn't all that difficult, just a matter of getting it to work. And of course, at the time he was trying to implement it, both the Dammit and ISOM inversion model sites went down. They had a bug in them or a virus, and at least the Dammit site is back up. I'm not so sure about the ISOM site yet. So that created more of an issue because we had no information coming in to test with. Okay, anybody have any questions or comments? What we need is more people observing, more chords. That's true. Yeah, I hadn't thought about that, and so maybe that caused us issues with the satellite being in a different location than we had thought. So hopefully all that will be taken into account, and we can come up with some new models for the asteroid and new positions for the satellite for next time. Because there's another one coming up for North America on 19th of August. So hopefully we can get some predictions for that and nail it down even better. So anything else? All in all, pretty good job. I'm going to put a message out now. There's not that many people listening, but I can use some help with some of these analyses, and it may not be the total analysis, but it might be just helping me out with getting the analysis started. So I might be posting something on the Yahoo group. Ted, the models are based on light curves. They have a program that they take and they import light curve information, amplitude and period, and they're able to then derive from the light curve a model for what the asteroid probably looks like. And as you might imagine, the more light curves, the better off you can resolve the details in the asteroid, because some of those little nooks and crannies are rather subtle. And so in order to, okay, you want me to turn off my audio and video, or you want me, because I can answer them in text if you want, either way. Any other questions? Light curves are always something that can be provided. You need to go to the Minor Planet Bulletin site to learn more about that, because it's pretty involved. As you can imagine, the light curves produced by the asteroids do not change in amplitude all that much. So you really need to be able to work on your equipment to get reliable information. A lot of comparison stars are needed that are not themselves variable, for example. And yeah, it's not easy work, but certainly people can do light curves. They're welcome at any time. And there's quite a group of amateurs that do that. The Association of Lunar and Planetary Observers has a group that does that, does light curves. And again, the Minor Planets Bulletin site is the one that you want to go check on. Okay. Still no Dave Harold, huh? Okay, that's all I have for that. And thanks everyone for your cooperation. The report forms are a big help. I appreciate people taking the time to fill those out correctly. As you might know, I run a macro to read the report form and place it into occult, and if the report form is wrong, the macro stops and I have to start looking for why the macro died. And sometimes it's easy and sometimes it's not so easy to find out why that happens. So, and I might add that if you use Occult Watcher and pre-fill the form using Occult Watcher, there has never been an error. You know, you might have made a mistake in putting the time down wrong, but the form itself is not wrong. So that's important to realize. A lot of people fill in the form themselves, and that's okay, but just be careful of errors when you do that. All right, I think I'm done. Thank you, everyone. Appreciate it.